Happy day, I am Dr. Aparna from the Department of Computer Science and Information Technology. In this session, I am going to explain the data pre-processing techniques in data mining and multidimensional modeling. This is the presentation flow of this session, starting with a brief introduction on data mining and its application areas. Then about the quality of data and various pre-processing techniques such as data cleaning, data integration, data reduction, data transformation and discretization. In this modern digital era, data is generated in different sources such as sensors, social media, smart devices and transactions. Data is generated in an unpredictable rate. Data by itself is like a crude oil, which is available in surplus but cannot be used as such. To harness the strength of the data, we need to analyze and pull out the insights, trends and pattern. This is exactly what data mining is all about. Data mining is a process of exploring and analyzing data to discover useful information and trends. Steps such as data collection, data pre-processing, data mining and data analysis plays a vital role in transforming the raw data into useful information. With the high volume of data being generated across all domains, data mining is essential in various sectors, particularly in telecommunication, education, finance, healthcare, marketing and retail sectors. In telecommunications, to identify efficient patterns, catch fraudulent activities, make better use of resource and to improve quality of service. In educational field, to analyze student performance data, predict learning outcomes and personalize educational experiences for improved academic achievement. In finance sector, to detect fraudulent transactions, assess credit card risk and support investment decision making by uncovering patterns in large financial data sets. In medical field, to predict disease outbreaks, enhance diagnosis accuracy and improve patient care by analyzing patterns in medical records and clinical data. In retail and marketing sector, data mining is applied to analyze customer purchasing patterns, optimize inventory management and personalize marketing through targeted recommendations. Quality of data is more important to pull out more useful information. Data quality is evaluated by various dimensions such as accuracy, completeness, consistency, timeliness, interpretability and believability, each of which plays a vital role in transforming the raw information into useful data which can be further analyzed and processed. Data collection is the first step in data mining, in which data from various resources are gathered for processing and analysis. There are 4 strategies in data pre-processing, namely data cleaning, data integration, data reduction, data transformation and discretization. In CRISP, data cleaning deals with removing error and noisy data. Data integration is to combine or merge relevant data from various sources for better decision making. Data reduction makes the data in more handleable way by reducing its size. Data transformation and discretization transforms the raw data into a suitable structure for further analysis and modeling. Now, let us look into the various data pre-processing techniques in detail. Data cleaning is the first step. It is a process of identifying and correcting errors, inconsistencies and inaccuracies in data sets to make it more accurate, complete, consistent and usable for further analysis and decision making. Since data is generated and collected from various resources, it will not be in an expected form. It may consider incomplete data. For example, some fields may not have been filled or may hold noisy data. Noise in a data is nothing but the error. Salary or price cannot be in negative. It is one such example. Inconsistency is a major issue, especially when dealt with derivable data. If age doesn't match with the birthday given, or referring the same items with different names also leads to inconsistency. There are certain situations where, to avoid missing data, default value is being set, but it will introduce intentional errors. Reason for incomplete data may be because of equipment malfunctioning, mistakenly deleted data in order to get rid of the inconsistency error, and some data being missed out while filling out in the data transactions. Missing data is a problem, but having an error data is even more worse, because error data leads to incorrect analysis and predictions. Next step is the data integration. Here data from various resources are relevantly matched and merged to make it as a single set for better decisions. Entity identification and data redundancy are the problems over here. If wrong data are matched and merged, it may lead to wrong results. Data redundancy can be spotted by correlation analysis and covariance analysis. Data reduction is the process of reducing the volume of data but without losing its essential information. Data reduction strategies includes the various dimensionality reductions techniques such as wavelet transformation, PCA, feature creation and selection, numerosity reduction by regression models, histograms, clustering, sampling and data cube aggregation methods. Then comes to the important data compression techniques, which can be lossy or lossless. Though lossless is preferred in many a times, achieving it always is not possible. Last is the data transformation and discretization, where the raw data in any structure is processed to a suitable format by various methods, which includes smoothing, aggregation, normalization, binning, cluster analysis, correlation analysis and so on. Here is an example for the binning method. Two types of data smoothing is illustrated for the binning. We have 12 items in the list and 3 bins. So, the first bin holds the first 4 items and the next 4 items are placed in the second bin. Last 4 items are in the third bin. So, this is the binning concept by equi-depth. Since the size of the bins are equal, it is also known as equal frequency binning. Next, the smoothing methods. So, after binning, smoothing by means or by bin boundaries is performed. Smoothing by bin means, in this method, the average of the bin 1 value is calculated. For example, in the bin 1 we have the items 4, 8, 9 and 15. So, the average of the item is 9. Hence, the bin 1 after smoothing will be having all 9 values. Similarly, for bin 2 and bin 3, its mean value, that is the average value, is replaced in the corresponding bins. Next method of smoothing by bin boundaries. Here, the upper boundary and the lower boundary is identified. For example, the bin 1 after the equi-depth binning is taken. For example, bin 1 will be having 4, 8, 9 and 15. Here the lower boundary is 4 and the upper boundary is 15. Now, taking it for smoothing, we have to examine each and every item in the bin and to match with the whether it is closer to the lower boundary or the upper boundary. So, the first item is 4. It is the lower boundary value, so it will be retained as such. Next, we have to examine the next bin value, which is 8, which is closer to the lower bin value 4 rather than the upper bin value 15. So, the 8 will be changed into 4. Next item is 9. It is also closer to the lower boundary value, so it is also being changed to 4. And moving on with the next last item in the bin 1, which is the upper boundary value. So, it will be retained as such. So, after smoothing by bin boundaries, the bin 1 will be having 4, 4, 4 and 15. Similarly, for bin 2 and bin 3, the lower boundary and upper boundaries are identified and each of the items are examined. Then it will be checked whether it has to be replaced by the lower boundary or the upper boundary, and hence the binning is performed. So, this is the smoothing method with bin boundaries. Hope this session is useful. Happy learning. Like, share and subscribe for more such videos. Thank you.